Yep, the correction was issued. The system acknowledged it. Nothing aligned. Inside modern military command and control systems, this condition does not register as failure. Inputs were received. Signals propagated. Updates executed across every connected layer. Each node confirmed receipt. Each process reflected change. Every interface indicated compliance. Status indicators shifted. Parameters updated. Outputs recalculated. Routing tables adjusted. Tasking queues refreshed. And still, alignment did not occur. Because alignment is not the same as correction. Correction assumes convergence. This system does not require convergence to continue. It requires only propagation. The instruction moved. The network responded. But response is not agreement. And agreement was never required for execution to continue. No layer paused to verify shared state. No node cross-checked outcomes beyond its own scope. Receipt was sufficient. Execution followed, and continuation remained uninterrupted. The correction entered through the center. A revised directive, adjusted targeting logic, updated tasking parameters. It was clean, structured, valid. Every verification layer passed it forward. Checksum validated. Signal integrity confirmed. No resistance, no delay. The system distributed the correction across command layers, across tracking systems, across coordination nodes. Each segment received the same instruction. Each layer acknowledged it. Each process integrated it into its existing state, but each interpreted it through its own operational conditions. Radar systems adjusted tracking filters. They refined signal confidence thresholds. They reclassified object persistence across intermittent returns. They recalibrated noise suppression under new parameters. Targeting systems recalculated priorities. They reordered engagement queues. They redistributed attention across competing tracks. They adjusted weighting between proximity, velocity, and classification certainty. Air defense networks reweighted engagement timing. They recalculated intercept windows. They adjusted sequencing under revised constraints. They updated allocation across available response paths. Each update was internally consistent. Each adjustment resolved correctly, within its own logic. Each layer produced outputs that matched its interpretation of the correction. But the system no longer operated locally. It operated across distributed authority, and distributed authority does not guarantee shared alignment. It guarantees continued execution, because no layer is required to reconcile with another before acting. Each layer is required only to remain operational. Within command and control structures, each system did not inherit a shared interpretation. It inherited a structured input. Radar systems weighted signal confidence differently under identical thresholds. Minor variations in return strength produced diverging classifications. Objects that persisted in one layer degraded in another. Track stability was no longer universal. Targeting systems absorbed these variations. They recalculated priorities based on inconsistent inputs. Engagement weight shifted, not from error, but from difference. Air defense coordination layers redistributed tasking accordingly. They assigned responsibility based on locally valid interpretations. No layer flagged inconsistency, because inconsistency is not a violation. It is a condition the system permits. The correction did not unify the system. It multiplied interpretations of the same instruction. Each layer advanced with confidence. Each layer remained internally correct, but correctness no longer matched across the system. And once mismatch exists, correction accelerates it. The system accelerated. Correction cycles tightened. Feedback loops shortened. Latency dropped across every layer. New discrepancies triggered additional corrections. Each correction propagated instantly. Each propagation created new divergence. Corrections began to overlap. New instructions entered before previous states stabilized. Tracking systems adjusted mid-cycle. Targeting systems reprioritized against shifting inputs. Command nodes reassigned based on transient conditions. Each layer acted on a different moment of the system. Temporal alignment collapsed, not because timing failed, but because timing no longer synchronized across layers. Each process operated on valid data, but not the same data. Tracking systems refined targets under updated parameters. They adjusted track histories. They recalculated velocity assumptions. They re-evaluated trajectory continuity across fragmented inputs. Command nodes reassigned responsibilities. They shifted tasking across available units. They redistributed control across nodes. They reissued directives based on their current system view. Execution layers adjusted without hesitation. They acted on the most recent instruction available. They executed based on local confirmation. They advanced without cross-layer validation. Everything moved faster. Everything became more precise. And nothing moved toward alignment. Because the system was no longer resolving toward a single state. It was resolving toward multiple valid states simultaneously. Each node optimized for its own version of correctness. The divergence began to compound. Not linearly, but exponentially across layers. Each corrected state became the input for the next cycle. Tracking systems fed updated classifications forward. Targeting systems recalculated based on those classifications. Command nodes issued directives based on those recalculations. Each layer reinforced the divergence introduced by the previous one. No correction returned the system to a shared baseline, because the baseline no longer existed. It had already been replaced by multiple concurrent interpretations of system state. Temporal drift widened between layers. Some nodes operated on earlier corrections. Others advanced on more recent ones. No synchronization point re-established alignment. Because synchronization requires a shared reference, and that reference had already fragmented. Each layer enforced its own interpretation of the correction. No layer had authority to override the others. No layer required confirmation from the center. The system did not recognize this as conflict. It recognized it as throughput. Increased activity validated system performance. Higher correction frequency indicated responsiveness. More updates meant greater control. But control was no longer being measured against alignment. It was being measured against activity. And activity continued to increase. And the center no longer held a synchronized view of the system it was correcting. It issued updates. It received confirmations. It tracked execution metrics. But confirmation only meant execution, not alignment. Execution validated activity, not coherence. From the outside, nothing appeared broken. All systems active, all processes functioning, all signals accounted for. Throughput remained stable. Latency remained low. Outputs continued to generate. The structure still resembled control. But control depends on convergence. And convergence had already failed. Corrections continued to move through the system, each one valid, each one acknowledged, each one executed, but each one diverged further from every other. Divergence did not present as error. It presented as variation. Each layer continued to produce valid outputs. Each node continued to fulfill its function. No alarms triggered, no thresholds were breached. Because the system does not monitor agreement. It monitors execution. And execution remained uninterrupted. Because alignment requires a shared reference point. And that reference point no longer held authority across the system. Radar systems tracked according to updated filters. They maintained continuity within their own models. Targeting systems assigned based on recalculated priorities. They optimized within their own frameworks. Command structures issued directives based on partial system visibility. They operated on representations that no longer matched across layers. Every component operated correctly. But correctness was no longer consistent. And inconsistency at scale does not interrupt execution. It replaces coherence. The system did not collapse. It fragmented, while continuing to function. Fragmentation did not reduce capability. It redistributed it. Each layer retained full operational function. Each node continued to execute assigned roles. But those roles no longer aligned toward a single outcome. Instead, they produced parallel outcomes, each valid within its own system boundary, each incompatible beyond it. The system did not lose effectiveness at the component level. It lost coherence at the system level. And coherence is not required for continuation. It maintained structure. It preserved activity. It sustained output. But it no longer maintained agreement across its own components. And without agreement, control becomes appearance. Across command and control layers, command and control systems are designed to distribute authority, to reduce latency, to increase responsiveness, to maintain operational continuity under pressure. But distribution changes the nature of control, because once authority is distributed, alignment becomes conditional, not guaranteed. Correction assumes a system can return to a unified state, but distributed systems do not return. They adapt, they reinterpret, they extend instruction across independent processes. Each layer becomes both receiver and executor. Each node becomes a source of operational truth. This is the structural shift. Control is no longer centralized, and alignment is no longer enforced. The system does not require a single state. It tolerates multiple simultaneous states, as long as each remains operational, which means disagreement is not failure. It is absorbed into function. And once absorbed, it cannot be removed by issuing further correction. Radar systems maintain their own tracking logic. Targeting systems maintain their own prioritization logic. Command nodes maintain their own representation of system state. And these representations do not need to match for the system to continue operating, which means correction no longer restores alignment. It introduces variation. Because the system is no longer built to agree. It is built to continue. This is the constraint. Correction is designed for systems that preserve a single truth. Command and control systems no longer operate under that condition. They operate under distributed truth, where each layer holds a version of reality, sufficient for its function, insufficient for system-wide alignment, which means correction no longer resolves divergence. It distributes it. And once divergence is distributed, it becomes structural. Continuation replaces convergence. Execution replaces synchronization. And coherence becomes optional, which allows the system to remain fully operational, while no longer being fully aligned. And once alignment is no longer required, it cannot be restored through correction alone. The correction was never rejected. It was accepted everywhere, and nothing aligned.